Okay, let's start. This will be 261. It's about the uh, elastic property behavior, and the question is asking the distance for the uh, gauge marks that is going to be extended. So we have 9 kilonewton, I think the P. So we have a force 9 kilonewton, the load for each endpoint. So also we have the diameter 13 millimeter, and then the original length is 50 millimeter. Okay, so first I think we can write first that the formula to get the elastic behavior is basically E is the sigma over this strain. Okay. Sigma is basically the pressure divided by the area, which is defined by the diameter. So this will be F over A. And the strain will be the delta L. We get the delta L from this information here, 0.05. So that will be the delta. So delta L over original length, right? And since we have a kilonewton, I will write as a Newton. So this will be 9,000 Newton. And then divide. I will write divide. The area will be pi. And I will take 6.5, the diameter. And then squared for the sigma. And then the strain will be L is 50 millimeter over the delta L is 0.05 millimeter. So Newton and millimeter, remember, whenever you have Newton over millimeter squared, the result will be MPa, megapascal. And that is something that is, I think, in material science or or mechanical in general. MPa is something that is we expect. Okay, so every time we have Newton, millimeter, we have megapascal. So we get, or if you're still in the kilonewton, the result will be a gigapascal, which is, I think, more suitable for the E. But let me just write in MPa first. I think if you calculate this, and you can try, it's supposed to be 67.8 thousand, around. Okay, so that's the E. And then I think this is not really long question. Suppose that we have the second question here, the proportional limit stress. Okay, proportional limit stress. So what is proportional limit? Okay. So to understand proportional limit, remember that proportional, usually if you have a, for example, we have, this is in some alloys, could be metals, any metals. This is a typical stress strain curve. So this will be stress strain curve. And the proportional limit, if you take the offset 0.2, which means that we take 0.2 here, or 0.2%, so 0.002. And then we take a linear straight line like that, and we call this is the approximation for the yield stress. Okay, approximation for the yield stress. So basically, here, so let me write here. So sigma proportional limit is the maximum stress in elastic property. I think we can write something like that. So all this is elastic, which means that this will be the sigma proportional limit. And the red line is the proportional method. Okay, offset method. Okay, this is we call the offset method. We take the line proportional to the linear property. Okay, usually the offset method to predict the sigma yield stress, or let me just write sigma yield like that. Okay. Okay, now if the sigma proportional limit is 310 MPa, then based on the modulus of elastic, we can get the strain. Okay, so the strain at the proportional limit is basically sigma divided with Young's modulus. So 310 divided by 67.8 . And strain is around this. I think you can check if I have a mistake, but I think the number at least may be different in decimals. I think it should be 4, right? 3, 6, yeah, it should be 4. Or maybe 5. Yeah, it's 4.45. Okay, now this is the strain. Remember, the question is asking the distance, right? The distance. So the final distance. So distance we could get from the delta L over L equal the strain. So the delta L will be the final length minus the original length, 50 millimeter, divided with the 50 millimeter. This will equal the strain, which is 4.57. And you solve this, you get the final length will be around 50.285. Or if you see, I think you can just multiply, get the delta L, and then adding to the 50, right? And perhaps another variation of this type of questions is perhaps if we have Like if you imagine that if this um, adding some extended length, like for example, it's become maybe longer, maybe it's become like that, right? So this is the final length, just for illustrations. Another questions can be asked is perhaps the Poisson ratio. So you have the ratio, the longitudinal, or if you prefer, horizontal and vertical. Vertical or radial, because it's a rod, things should be okay. So Poisson is negative, strain vertical over strain horizontal. Yeah, as long as we know the changes, I think we could get the Poisson ratio. Okay, so that's the example. Okay, this one we have done. Okay, let's check this one. Okay, it is still in the design, allowable stress. I think similar questions. So let me. Maybe let me write here. Okay, check this out first. And if you have the file or the textbook, you can check the other question as well. And perhaps I will give more in exercises. And as I mentioned yesterday, I will upload assignment, okay, about chapter 1. Okay. But I think if you your quiz score maybe above 70, you don't need. But if you want, that's okay. But the calculation will be different. Okay, calculation will be different. The percentage will be different. But still adding some points. Okay, I just realized like Friday is, we have holiday, right? No class, right? Friday? Yeah, I just realized I forgot. Okay, so what should we do first? Okay, what should we do first to get to know? Maybe, since we know all the height and the base for the triangle, on the left, right? The triangle on the left, we know all of them. So perhaps we can know the length for the other sides for example, the AB and BC, right? AB and BC. So we could get from just plug in a Pythagorean. I think should be okay. So AB, this is we get from 600 and 450. This is 700, right? Or I think I will write in meter in case there are other problem with the units. I think in the meter I will. But I think if you've done in millimeter should be okay. I think no problem. Okay, and then the same for BC. Okay, and this must be another Pythagorean, and it should be right geometrically if you can observe. So 1200 minus 750, right? This will be 900 something, or I will just write 0.96 millimeter. Okay. And then what else do we have here? Again, we have a pin at A because we want to know the reactions. The question is asking the cross sections. So we have allowable the limit for the each tension or compression, and we have the load maximum, which is 50 kilonewton. So based on the 50 kilonewton and the allowable for the tension and compression, then we need to find what will be the limit for the area. Okay, so to get to know that, we need to know the reaction force. So at A, suppose that we have something on there, and let's say we have a direction on the right, but I expect the horizontal will go to the left. Okay? But let me just go to the right, okay, just to prove that we are on the right directions, or to prove that there will be negative in the result. So it should be go to the left. And then for the C, since it's a roller, we have only vertical, let's say CY. So we have P, which is 50 kilonewton, or 50,000 Newton. So since A has a lot of forces, so I will make A as a point of view. So moment at A, take the moment at A equals 0. And then let me take a straight line here just to help navigate the moment distance. So first is P, and we define first which one is positive. I think this one will be positive. So P and 600, or 0.6. And then minus CY 0.12. This will be 50,000. So Cy will be, we divide by 2 basically. So this will be equal to 25,000 Newton, or if you want to write in kilonewton, you can write 25 kilonewton. And then, well, I think to make space, let me write all of this on here. Forget that. And let me go up. Oh. Okay. And then take the sigma force for x and y. So let's take for y. So AY we know from the CY. So oh, let me write with black color. So AY plus CY equals 0. So AY is minus 25,000 Newton, or negative 25 kilonewton. And then sigma Fx equals 0. This will be AX plus P equals 0, or AX is negative 50,000 Newton, or negative 50 kilonewton. Okay, and then we want to know the truss, right? Each truss, right? So we are going to take, maybe start from 1 or 3, and then because we know the C, right? We know the C, only CY on the C, right? So we could take observation only for a C. So observe point C. So we have, here is the F3 and F1. And then the CY, right? We have CY here. So we are going to take the sigma F, right? Maybe Y first. So suppose that this is the angle. But since the triangle is not right triangle as usual, so we are going to use the other angle to let the so this will be or let me just write in the new one here. And we have another one here. So this will be AB over BC, right? AB over BC for the, so F3 AB over BC plus CY equals 0. So F3 is negative CY, and then BC over AB, right? BC is 0.0 millimeter, 0.96. So this is minus 50,000 Newton, 0.96 meter over AB is 0.75 meter. Okay, it's supposed to be negative 40,020 Newton. Okay, around. Maybe different will be the decimals. I think I'll write with the too big, so let me resize. And then from the same sigma or the same point C, we can get the sigma fx, right? Sigma fx will be f1, and f3, right? Now f3 will be this size. I forgot to take this distance here. Distance here is 750, right? 750. So I will write here 750. Maybe this is D, okay, to help out. So F3 BD and then BC and then plus F1 is 0. So we get F1 is negative 4020 and then BD 750 or 0.75. I will write in meter. And then BC is 0.96. Oh wait. This should be not 75. I've wrong here. So this should be 600, right? Right? Yeah, now it's correct. Maybe check the number. Is this number correct? Can you check the number? Let me check this one. Is this correct? I have 0.6. I think the digits different, right? Can you check? Let me check. So need to add 0, right? Do you do you think so? That one, okay. Well, you need to check the forces. Let me just write first, and then I think the formula all correct, but you need to check the number. Okay. I think there's something wrong in the number here, which this is going to be taking only 5,000. Yeah, should be 5, right? Oh, wait. I did something wrong here. It's supposed not 0.12, right? This is 1.2. That's why I'm wrong. Okay. Now I agree. Now. Okay, this should be the F1 should be around this should be positive because the F already in negative, so this should be positive. So 3, 1, 250 Newton. And then at B, we can also observe what's happened at B to get the last. So at point B, we have the F2 over there and F3 and the B. Okay, since we only want to get the F2, I think I will just take only the vertical axis. So let's take the sigma F y equals 0. So we have that, right? And also for the F3, we have also that. I will write just the final equations. So AB over so 450 divided by 600 millimeter multiply with the F3 will be the 600, right? Divide with BC BC is 960 millimeter F3. This you get the same 3, 1, 2, and 50 Newton. Okay, so all the forces we get, then for each one of them, A1, A2, A3, we take all the F1 divide with. Now we need to make sure which one is the tension, which one is the compression, and that is how we define the sigma. This is could be tension or compression. So let's say we have the F1. The F1 result is positive, right? It's supposed to be tension. This is compression. This is tension. So this will be using the tension. 3, 1, 20, 22, 50. So tension, we take tension is 150 megapascal, 150 Newton over millimeter squared. So this is Newton. So we have, this is around 3.2 millimeters squared. And then A2, F2 over sigma T. F2 is 31250. This is the same. And A3 will be the compression. Compression is negative 90. This will be 444.7 millimeters squared. Okay, that's the required for the area. Yeah, I think that's all for today's class. I have uploaded the notes and the answer key for the exercise. Oh wait, this is BE. Forgot to change this, not AB, sorry. Should be BE. And this is BE. I think you need to check the number again. I think the number is wrong. The number is wrong, but the formula all correct. Right? Can you check? I think wrong calculations. Up until the upper part should be okay. but below for each F1, F2, F3 they are, I think, wrong number. I will prepare again, so when I upload this I will make sure the number are correct. Okay, let me just write here, numbers are wrong. Okay, so yeah, I think that's all for today. For the quiz 1, do you think you need to review again in class or not? If we need, then next week I will put one question on chapter 1. Do you still need or no? Because I think the midterm will be 1, 2, and a little bit 3. But I think 1 will be everywhere. Because you see that the question will be evolved, right? Will be evolved. So maybe the same picture, but adding more specific questions, something like that. So the first step, usually we are going to have a free body diagram, use equilibrium, which is from the chapter 1. Okay. So I think I will get into that basic. Wait a moment. I think this is the attendance. If you're still struggling on the basic, especially statics, let me know. I think I will suggest you for some tutorial as well. That is perhaps easier and it has more practice questions. Oh, I know what is wrong. I use 50,000 for CY while CY is 25,000. I just realized this should be 25. Okay, later I will fix this.